Welcome to another edition of Brain Maths. On this edition, we want to look at how to solve the set questions on the board following the theory and the laws of logarithm. Looking at the first question, it says logarithm in base 10 of 5 plus logarithm in base 10 of 2. Don't forget that the two logarithms are in the same base. So we can connect them together using the law of logarithm that says whenever you have logarithm to base a of m plus logarithm to base a of n can be rewritten as logarithm that is common to the two of them, bringing the two together as m times n. So we are going to connect the two together. So we have logarithm to base 10 of 5 times 2, which is equal to logarithm in base 10 of 10. Don't forget from our previous lessons as well that whenever we have logarithm to the same base and the same number, the answer is going to be what? 1. Question number 2 says 1 over 2 log 10 of 25 over 4 minus 2 log 10 of 4 over 5 plus log 10 of 320 over 125. Now, the first thing we need to do here is to remove this whole number from the front of the logarithm and put them at their expected position. Where are we expected to put them? If you don't forget the rule that says n log a of m, it is going to give us log a of m. This n will come back to the power position. So that is the same thing we are going to apply to these two. So taking account of those, we are going to have logarithm to base 10 of 25 over 4 raised to power half minus these two will also go back to its original position, which is 4 over 5 raised to power 2 plus logarithm in base 10 of 320 over 125. So there is another law of indices that says whenever you have a raised to power 1 over 2, if you don't forget your laws of indices, a raised to power 1 over 2 is the same thing as square root of a. So applying that into this, we have logarithm in base 10 of 25 over 4 minus logarithm in base 10 of 4 over 5 raised to power 2 plus logarithm in base 10 of 320 over 125. So the square root of 25 is what? Right here you say 5, yes. And the square root of 4 is 2. Minus logarithm in base 10. This square is going to be used to open that bracket, and that will give us 4 times 4, 16 over 5 times 5, 25, plus logarithm to base 10 of 320 over 125. So if we look at this closely now, we'll see that it is easy for us to apply the next rule of logarithm, and that is to collect the like times, which is log 10. So collecting the like times now, we have logarithm to base 10, open a bracket. The first one is 5 over 2. This minus will change to divided by 16 over 25, and the plus will also change to times 320 over 125. So the next thing is to change the division to multiplication. And from our primary school rule, wherever we have division, changing to multiplication will give us the numerator and the denominator will interchange positions. So we have 25 over 16 times 320 over 125. So now all we have to do is to look for ways to break this down. 5 here 1, 5 in 125 will give us 25. 25 will cancel 25. 16 in 320 will give us 20, and 2 in 20 will give us 10. So we are left with logarithm in base 10. On the numerator part, we have 1 times 10, which is 10. And in the denominator side, we have 1. So we are left with logarithm to base 10 of 10 over 1. And 10 over 1, you agree with me, is the same thing as 10. So we have logarithm to base 10 of 10. And if you don't forget the rules, as usual, we'll keep talking about the rules because that is what we are using as a guide. So logarithm to base 10 of 10 is 1. And that is the solution to that question. Question number 3 says logarithm 3 log 4 of 2 plus 2 log 4 of 4 minus log 4 of 8. So the only thing we have to do quickly is to take the whole number back to their original spot, and that will give us logarithm in base 4 of 2 raised to power 3 plus logarithm in base 4 of 4 raised to power 2 minus logarithm in base 4 of 8. So this will lead us to logarithm in base 4 of 2 raised to power 3 is 8 plus logarithm in base 4, 4 raised to power 2 is 16 minus logarithm in base 4 of 8. Base 4 is common to everything. So we have logarithm in base 4 out. We are left with 8 times, don't forget the plus we change to times, 16 divided by 8. So this will lead us to logarithm in base 4 of 8 times 16. This one is going to change to times, and that will make this to become 1 over 8 divided by 8. And that is 8 cancelling out 8 on the numerator and the denominator side. So we have logarithm in base 4 of 16. So what we have to do here is to rewrite this 16 to the power of, to the base of 4. So how many times are we going to multiply 4 to give us 16? So we have 4 raised to power 2. That is 4 times 4. So applying the law of logarithm that says whenever you have a power, you can bring it down. So it becomes 2 logarithm to base 4 of 4. And don't forget, any logarithm having the same base and the same number is the same thing as 1. So we have 2 times 1, and that will give us 2. So the answer to that question is actually 2. Logarithm in base 5 of 4 minus 2 logarithm in base 5 of 5 over 6 plus logarithm in base 5 of 625 over 144. So this is the only thing we are going to move to this side. So this is going to give us logarithm in base 5 of 4 minus, if this get back to this point, so we have logarithm in base 5, it becomes a square, and that is going to give us 25 over 36 plus logarithm in base 5 of 625 over 144. So on this note, we collect the like time, which is logarithm in base 5 into 4 divided by 25 over 36 times 625 over 144. So we have logarithm in base 5 of 4 times 36 over 25 times 625 over 144. So in this, 25 here 1, 25 in 60, that is 2, remainder 12, and 25 in 125, that is 5. So 4 here 1, 4 in 14, that will give us 3. In 24, that is 6. 36 here 1 and 36 here 1. So we are left with logarithm in base 5 of, we are only left with 25 as the remainder in our answer. So that 25 can be broken down. We can break it down into logarithm in base 5. 25 will give us 5 raised to power 2. And if the 2 comes down, we have 2 logarithm in base 5 of 5. And 5 of 5 is the same thing as 1. So our answer for this question will also be 2. The last question says logarithm in base 3 of 12 minus logarithm in base 3 of 16 plus 2 logarithm in base 3 of 6. So the only one we are tackling first is this. And that will give us logarithm in base 3 of 12 minus logarithm in base 3 of 16 plus logarithm in base 3 of 6. If this come back to its original point, raised to power 2. So we have logarithm in base 3 of 12 minus logarithm in base 3 of 16 plus logarithm in base 3 of 36. So collecting the like times now. Logarithm of base 3 is common throughout. So we have logarithm in base 3. You open a bracket. We have 12 minus changes to division divided by 16 over 1. Then the plus changes to times 36. So we have logarithm in base 3 of 12 times 1 over 16 times what? 36. So let's break this down. 4 here, 3, 4 here, 4, 4 here, 1, 4 here, 9. 3 times 9 will give us 27. So we have logarithm in base 3 of 27. So we want to rewrite 27 to the base of 3. And that will be logarithm in base 3 of 3 raised to power what? 3 times 3, 9. 9 times 3, 27, which is raised to power 3. Don't forget that the 3 will come down, giving us 3 logarithm in base 3 of 3. And logarithm in base 3 of 3 is the same thing as what? 1. And that will lead us to the final answer, which is what? 3. On this note, we have come to the end of yet another edition of Brain Maths. Don't forget to subscribe to the page if you have not done so, and also turn on the notification so that you'll be among the first to be notified. Do have a blessed day. Thank you.